Formulas occur frequently as math models. Many formulas contain rational expressions, and to solve for formulas for a specified letter, we proceed as when we're solving for rational equations. So basically, the first item of this section 6.8, formula applications and variation, is to be able to solve for a specified letter. So here is an example of a formula that maybe represents something, but then I just want to solve for the letter V. And to solve for the letter V is basically trying to isolate V. So to solve for V, we take what we see here, and then we want to get rid of the letter P and the letter T, and that will solve for V. So how do we get rid of the letter P? Well, I'm gonna put a P down here. If you're gonna put a P down there, you're gonna put a P over here. And then how do I get rid of the letter T? Well, I'm gonna put a T up here. And if you do that, then you gotta do it over here. So what happened? Well, this T will cancel out, so will this P. So what do you have left? We have V left, and then over here on the right side, we have little a times big T, and then we have little b times P, big P. And there you go, you solve for the letter V. Alright, so solve for V or solve for whichever letter means that you just try to isolate that letter. Let's try to solve for R in this problem. So notice that I had P equals to A over 1 plus RT. So how do I solve for R? Well, to solve for R, what I'm going to have to do is I am going to have to try to get R to be on top. Now, the way how to do that, there's a lot of ways, but one way is to multiply both sides by 1 plus RT. So I'm going to multiply this by 1 plus RT. And the reason why I'm doing that is because I'm trying to get R on top. When I do that, these two cancels out, but now I have R on top. So I have 1 plus RT P equals to A, because that cancels out, that equals to A. Remember, I'm trying to solve for R, so I'm going to divide both sides by P. So let's divide both sides by P. And what we have here is we have 1 plus RT is equal to A over P, because the P here cancels out. See, I'm slowly isolating my R. I need to subtract 1 to both sides here. So now I end up with RT equals to A over P minus 1. And then last, I divide both sides by T. And that allows me to solve for R. So at the end, this is what R equals to. R equals to A over P minus 1 over T. So now that you learned how to solve for formula, let's move on to what we call direct variation, inverse variation, and joint variation. What is direct variation? Direct variation represents a situation where when one quantity increases, the second quantity also increases. For example, let's say if the more hours you work, the more money you make. So as one quantity increases, the next quantity also increases. So as soon as anything that goes hand in hand, that has a direct relationship, we call that a direct variation. We usually write direct variations like this. So a lot of times when you look at a problem, it's going to tell you that something like object A vary directly with object B. So let me give you an example. Y, if you see, for example, Y varies directly as X, this is what we mean mathematically. We mean that Y equals to K times X. K is what we call our constant of variation, In other words, as X increases, Y also increases. So K is kind of like that factor, like how much does it increase by? Does it double? Does it triple? And so on and so forth. Inverse variation. Inverse variation is a little bit different. It has a negative effect. When one variable goes up, the other one decreases. So for example, if interest rate does go up, guys, then house prices would likely go down because they do have an opposite effect from each. So when you see something like y varies inversely as x, mathematically, here's what we mean. As y or as x goes up, y goes down, and y goes down by some constant factor. We also call that constant factor k, constant factor. Now, joint variation is when there are two or more variables that are directly related. So we'll talk about that case when it arises. Find the variation constant, that's that k value, and an equation of variation, which is this equation, if y varies directly as x, and y equals to 15 and x equals to 3. So notice that we see y vary directly as x. By seeing that, I'm able to translate that into something like this, into my mathematical formula. And then the next thing we see is we're given some information. So the next step is we find k. Find k. And to find k, we basically take the information that they give us, which is y equals to 15 and x equals to 3, and then we plug it in. So I'm going to plug 15 in for y, and I'm going to plug 3 in for x. And if I divide both sides by 3, then that means that k equals to 5. So now, using a given information, we know what the constant of variation is, and therefore we can form an equation. So our equation is going to be y equals to 5x, and we're done. This is our constant of variation, and this is our equation of variation. So as x goes up 1 unit, y's go up 5 units. Think of it this way: for every hour that you work, you get 5 hours of. You can think of it as you get 5 minutes of vacation time. All right, and you work 2 hours, you get 10 minutes of vacation time, and so on and so forth. So as one item goes up, the other item also goes up. If y varies directly as x and y equals to 4 when x equals to 3, find y when x equals to 9. So here, in addition to finding an equation, it also asks us to find a specific y. So there are a few questions here, but in order to answer this question, we have to come up with an equation first. So what we usually do is we usually take this first line, y varies directly as x, and that allows us to translate that into our mathematical model, which is y equals to k times x. From that line, y varies directly as x. And then the next thing we do is we use the given information to find k. So to find k, we take this and we plug it in here, which equals to 4 equals to x times 3. So therefore k equals to 4 over 3. Once we found out that k equals 4 over 3, then we now replace k with the value that we have found. So this is our direct variation equation. So once we have the equation, then we can basically answer the question, which says that find y when x equals to 9. So then we would plug in 9 here, and then we can simplify, cross cancel, that leaves it with 3, and 4 times 3 equals to 12. So when x equals to 9, y equals to 12. So as you can see, when x is small, y is small. When x is larger, y also gets pretty large. So y varies directly as x. The distance that an object travels is directly proportional to the amount of time since it began traveling. An object travels 512 feet in 4 seconds, so we can let y equals to the distance that it has traveled, and x stands for time. We usually use t for time, but in this case, let's just use x. Find the distance the object travels in 5 seconds. So find the distance. So we're gonna let y be the distance when the time is 5 seconds. Now this is a direct variation. Another way to recognize direct variation is when you see directly proportional. That's another way to recognize that it is direct variation. So what you do once you have summarized the information is you write the equation that we use to model a direct variation. And the next thing you do is you use the given information to find k. So plug that in here and that allows you to find k. So 512 goes for y, and then 4 goes for x, and then divide both sides by 4. That allows you to solve for k. So when we take 512, divide that by 4, that brings it to 128. So then you have y equals to 128x. From here, we are going to plug in 5 for x, and that allows us to find the y value. So then we plug in 5 for x, and that allows us to find the y value, which comes out to be 640 feet. So we expect the object to travel 640 feet in 5 seconds. Inverse variation. As one value goes up, the other value goes down. That's an example of inverse variation. So when you see the statement y varies inversely as x, then first translate it into y equals to k over x. Alright, because the value is inverse. And you will be given some information. So in this problem, as you can see, we're given that y equals to 2 and x equals to 64. And they're also gonna tell you to find something. So they want you to find y when x equals to 4. So we are going to first use the information to find k so that we can complete the equation. So use the information to find k. So maybe here write find k, plug x equals to 64 and then 2 for y. And if we multiply both sides by 64, turns out that k equals to 128. And then we will now take this number and plug it back in here, and that becomes our equation. So 128 over x. So once we have found the equation, then we can find the missing value by plugging in the x value. So y equals to 128 over 4. And that will bring us to 32. So y equals to 32. Right. As you can see, when x goes, as one value goes up, the other value goes down. So when x equals to 64, y equals to 2. When x equals to 4, so as one value goes down, the other value goes up. So when x equals to 4, which is down from 64, y goes up. Y went up to 32. It went from 2 to 32. Voltage. Voltage is something that you can find in electricity and also in what we call an electric circuit. So voltage is an electric circuit that is held constant. The current, we call the letter I for current, varies inversely to the resistance. So from this sentence right here, we can translate that this is an inverse variation. So the current varies inversely. Inversely starts with the letter K over R. Okay, that's an inverse variation. And they're gonna give us some information. So by reading further, if the current is 280 amps, so it is given that I stands for the current. So I is 280. When the resistance is 3, so R equals to 3. So that's our information. And then they're gonna ask to find something. So find current when resistance is 12. So find the current, find I when the resistance is 12. So from these information that we have, we use the given information to find K. So find K. So we take it and we plug it in, so we get 280 equals to k over 12, and then you would multiply both sides by 12. That allows you to find k, so k equals to 3,360. Once you find k, then you take that and you plug it in here, and that allows you to complete the equation. From here, then you can answer the question that they want you to find. So the fact that they said r equals to 12, you plug 12 in there, and you have 3,360 over 12. That means that the current is going to come out to be, take 3,360 and divide that by 12. That comes out to be 280. Joint variation. Joint variation is when two or more items varies according to maybe direct variation to another item, and so on and so forth. So the translation for joint variation will kind of depends on the equation that's given to you. Find an equation of variation if A varies jointly as B and C, and A equals to 48 and B equals to 4. So A varies jointly as B and C. From here, we can come up with the equation A equals to this constant K times B and C. So one way to think of joint variation is as two quantities increases, the other quantity also increases. For example, home prices might go up. A could stand for home prices. Home prices might go up if people have a higher income, and maybe the economy is picking up where they would use C to represent another factor. Okay, so as two things increases, A also increases. All right, so from the equation, then now we're gonna go ahead and identify the given information, which is A equals to 48, B equals to 4, and C equals to 2. And the whole purpose of using the given information is to find the equation. And to find the equation means that we have to fill in what K is. So we go 48 equals to 4 times 2. So 48 equals to 8K. And that means K comes out to be equals to 6. Therefore, our equation for this joint variation is going to be A equals to 6 BC, and that's your equation. So as B and C increases, A increases by a factor of 6, the product of B and C. Okay, let's do one example of joint variation. Find an equation of variation if Y varies jointly as X and Z. So Y varies jointly as X and Z, okay? And inversely as the product of W and P. Now, the fact that there's inverse added here, that means that this equation, in addition to varies jointly, it also varies inversely as the product of W and P. So W and P actually goes down here. So whatever is inversely, you always divide. So that's our equation that we're able to kind of come up with. The next thing we do is we look at the given information. So the given information is X equals to 24, Y equals to 60, Z equals to 5, so that's, and Y equals to 60, Z equals to 5, W equals to 2, and P equals to 3. W equals to 2, and P equals to 3. So we are given this information, and it asks us to find an equation. So all we have to do is take this information and plug it in here so that we can come up with an equation. Plug in here to find K so that we can fill in K to come up with an equation. So find K. So we go Y, which is 60, equals to 24, which equals to 5, and then down here you have W, and then you have P. Therefore, this becomes 6 times 4 is 240. Then you have 5 times 4 is 20. 5 times 2 is 10. With the remainder of 2 is 120. So you have 120K. And then if you divide both sides, you get K equals to 2. So once we have found 2, then we pick that, we plug it in here for K. So our equation comes out to be 2xz over WP. And that is the equation that's jointly varies and also inversely varies with the W and the P.